Okay, so here's a problem that came across my desk. Let's solve a quadratic, and this one's fairly simple. A is 1, and we're going to use the factoring method on this one. Okay, the first step we want to do here is to put it into standard form for the method we're using. So I'm going to move everything to the left in descending order, moving all terms to the left in descending order. So I'm subtracting 4 from both sides to move that constant to the left, even though I usually move my constants to the right. So that's going to give me x squared minus 4x minus 5 equals 0. So this is now in standard form. All of the terms are on the left side of the equation equal to 0. And it's worth noting that you can also call the solutions zeros, or in other words, what value of x caused this entire expression to equal 0. And this time we'll use the factoring method. This is factorable, and let's just talk about how we know it's factorable. The quadratic coefficient here is 1. We call that a. Our linear coefficient is -4. We call that b. And our constant term is -5. We call that c. And if we use a part of the quadratic formula called the discriminant, which is b squared minus 4ac. And again, some of you can just look at this quadratic and know that it's factorable, but what if you can't, right? What if you don't just look at it and know that it's factorable? This is how you can tell. Okay, so b squared, which would be -4 squared, would be 16. And then -4 times 1 times -5 would be positive 20. And 16 plus 20 is 36. Now I'm going to circle that. That is not my solution. That is my discriminant. And this discriminant tells me a few things, including what matters right now for us. Because this discriminant is a perfect square, 6 squared makes 36, that's a perfect square, that tells us that this quadratic is factorable. So we're not just wasting our time trying to factor a quadratic that's not factorable. And so this is going to factor into two binomials multiplied together. And since a is 1, all I have to do is ask myself what factors of c have a sum of b. What factors of c have a sum of b? What two numbers multiply to make -5 but add to make -4? And that would be what? Let me think about that. Oh boy. How about a -5 and a +1? Okay, that took me a while to think about, but that's okay. And then each of these linear binomials has to start with an x, because x times x is how you make x squared, right? And it's just 1x squared, so we know that part. So now from there, although the solutions are kind of obvious from here once you have some practice, or obvious really from the beginning, once you really get good at this, you could just look at it from the beginning and kind of know what the answer is. But from here we use what's called the zero product property, where we give each factor its own separate equation equal to 0. Okay, because this quantity represents a number and this quantity represents a number. So we have two numbers that multiply to make 0, and that means one or both of them have to make 0, because the only way you can multiply to make 0 is if at least one of your factors is 0. So what would make x minus 5 equal 0? And what would make x plus 1 equal 0? So we're just going to solve those two equations separately. I like to call them splits. And we're going to add 5 to both sides on this one. We're going to subtract 1 from both sides on that one, just moving our constants to the right. Cancel, 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 cancel. And we get x equals 5 and x equals -1. So our solution set contains two solutions, -1 and 5. Technically, we should substitute them both back into the original equation to see if they're true, in case we get any extraneous solutions. But there we go. Let's start back at the top. We started with a quadratic equation. We moved it into standard form. We use the discriminant to find out that it is factorable because the discriminant's a perfect square. So we factored it. What factors of C have a sum of B, right? These two numbers here multiply to make -5, but add to make -4. So that's how our factoring worked there. And then each factor got its own separate equation using the zero product property, solving each one for 0 to get our solution set. If you have a math problem that you would like me to demonstrate, put it in the comments and I will. Hope that helps.